learn about graphs of proportional relationships. Before we get started, we need to recall how to plot points on a coordinate plane. So just a couple refreshers. See if you can identify the coordinates of a few of the points here on this graph. Pause to practice some of those coordinates. Point A is at coordinate 2, 4. Remember, the x-coordinate comes first and the y-coordinate comes second. The x-axis is the horizontal or side-to-side axis, and the y is up or down, vertical. The B is at point 3. C is at point -2, +1. D is -4, +4. And E is -6, -3. F is -2, -4. G is +2, -3. And H is +5, -2. Before we talk about graphs of proportional relationships, which one of these graphs would you think shows a proportional relationship and why? If you thought the graph on the left with the red line, you would be correct. Let's talk about why that is the proportional relationship. If you notice, both of the graphs are increasing at a constant rate, showing a straight line. The difference between these, however, is that this first graph starts at 0, 0, which means that the relationship is going to start from 0 and increase at a constant rate from 0. This graph starts at 5 and then increases from there, which means that the first pizza doesn't increase in value from 0, it increases in value from 5, which means it is not proportional. We want every point to increase proportionately from 0. So for a graph to be proportional, it must be a straight line, but it also must go through the origin. Just like we talked about in the last lesson, when you're trying to find the constant of proportionality from a graph, you're going to ask yourself the same questions that we asked ourselves when looking at a table. The x value times what equals the y value. The difference is that here we're going to be looking at values on an coordinate plane. So you're going to be looking at points on a graph instead of points in a table. So that's why we need to remember that the x value comes first and the y value comes second, because we want to know which value are we trying to figure out. So x times what equals y. It's the same order and the same direction as the tables that we looked at yesterday. X times what equals y, and if you don't know that, you're going to divide y by x. You can even take the table or the points from the graph and turn them into a table if you find that helpful. So here's what we want to do. We want to try to use the graph to find our constant of proportionality, or our unit rate, which is what we talked about yesterday. First thing you want to do is look for the point where x is 1. And if you can find that point clearly on the graph, whatever the y value is when x is 1, that is your unit rate. If you can't find the point where x is 1 on the graph for a few reasons, and I'll show a couple examples, then what you want to do is choose a different point on the graph that is a clear, identifiable point, and I will show you what that means. And then you want to use that to find the unit rate by asking yourself, x times what equals y, keeping in mind that x comes first, y comes second in the ordered pair, and also keeping in mind that the x-axis is the axis along the bottom and that the y-axis is the axis that goes up and down. So let's take a look at a couple examples. If Allison works at a bookstore, the amount of money she earns is proportional to the number of hours that she works. Find the constant of proportionality. So we talked about finding points on a graph. This line has infinite number of points on this line. We want to be able to identify points that intersect on a grid line. So here's one right here. Here's another one right here. A third one, and a fourth one. The first point is at x equals 1 and y equals halfway between 10 and 20, which is 15. So that's 115. Our second one here is 2 and 30, 3, then 45, and finally 4 and 60. The first thing to look for is, can you find the point where x is 1 on the graph? Is that a point that we can read? And the answer here is yes. We have the point clearly defined where x is 1 and y is 15, which means that our unit rate is just simply $15 per hour. If you aren't sure, you can also use the other points to help you determine, like we said, x times what equals y. Remembering that our first number in our ordered pair is x, so 1 times what is 15, 2 times what is 30, 3 times what is 45, and 4 times what is 60, and the answer to all of those is 15, and that's $15 per hour. Bringing back what we talked about yesterday with writing an equation, what is the equation that would relate the wages to the time? So we know that the amount of time that Allison is working times 15 equals the amount of money that she earns. So it's the number of hours times $15 per hour equals the amount of money that she earns. So H times 15 equals W, or W equals 15H if you follow the formula that I gave you of Y equals the unit rate times X. If you're having trouble figuring out which variable goes where, in this case, the Y represents what's on the Y-axis. So that's your wages, which is W. So that's why I replace Y with W. And our X values on this graph are time and hours, so that's why X gets replaced by H. On this example, if you notice, these ones already have some points identified for you. Notice that we do not have clearly marked on here the point where X equals 1. This value of the X-axis, these values are counted by 3s. So in order to find where X was 1, you would have to be making an estimate here, which we do not want to do. So instead of doing that, we're going to use the other values that are given in the table or on the chart and graph to answer what the constant of proportionality is. So 3 times what is 6? 6 times what is 12? And 9 times what is 18? And that's 2 millimeters per day. How many days would it take for the plant to be 54 millimeters tall? That would be 27 days, because 54 divided by 2 is 27. Take a moment to pause and try this example. In this example, we have the point 5, 6, because this is counting by 2s. That's 6. And 10, 12. And 15, 18. 5 times what is 6? 10 times what is 12? And 15 times what is 18? That answer is 1.2. So the distance hiked, which is your Y value, is 1.2 miles per hour times the number of hours that you hike. D equals 1.2H.